Hello everyone, today I am going to deliver another lecture on weld connection. There is no bolt connection. I have been deliver another lecture on bolt connection. That's why I am not uh, deliver or I'm excluding this bolt connection. So let's start how we'll design the bolt connection in the steel structure. So before I'm going to the deliver the wired connection, I want to say some theory, which is we need to know what is the E60 axis. This means 60 ksi, and E17 axis, which is 17 ksi, and AWS mean American Welding Society, and AS team American Society of the Testing Material. So there is the five type of joint we have been seeing: the bar joint, lap joint, tree joint, corner joint, and edge joint. So this is the bar joint. We can see in the picture. A plate is welding, and at the middle of the plate, this is the bar joint. And lapping joint we have been seeing here. The two plate are welding at the corner of the plate. This is the lapping joint. And the tree joint, the two plate are making a form of T, and jointing, and the weld is given on the between two plate is going the tree joint. Okay, and the corner joint have been seen in this figure, and end joint is also given here. So factor affecting the equality welding connection, we can see the proper electrodes and welding apparatus and the procedure, and then proper age of the preparation and control of the distortion. What is the possibility defect of the welds? So there's some defect. We can see the incomplete fashions and inadequate joint of penetration and porosity, and then undercutting, and then incursion of the slag and cracks. So we can see another picture, which is the T joint. So how we'll calculate this is the this distance, which this distance is 0.707 into a. This is the constant value. How we'll get if the a value is varying, then the value will be a b equal to root over a square plus b square, which is when the using unequal length. But as usually in the practical field we are using the equal length. That's why you are using 0.707 root over a. This is nothing but this is the how we'll get, we can calculating it geometrically and found this value 0.707 a. The maximum fillet weld inside along the axis, which is called mx. How we'll get the mx? When t equal to less than 1 by 4, 4 this is then mx equal to t minus 0, which is 1 by 4. So how this is the mx of the vertical distance of the mx. We have been doing the welding is given here, and the t is the thickness of the plate. When t is greater than 1 by 4 inches, then we are calculating t into 1 divided by 16. As we know, the 16 is a constant value in the previously when we use the hole. On the other hand, if you use the bolt, then we will use the 1 by 8. Okay, let's done it. So mx will be 1 t minus 1 by 16. So these are given in picture here. So before in going to here, so I want to taking some I have collected some notes which is taken Professor Dr. Amanos sir, Department Civil in Buet. So we've been taking I must be reference his lecture note, and we've been taking we have been seeing the same things in here. Here some same things, and Grobern weld, we have been seeing Grobern groove welds and fillet welds, and the plug welds and the short welds. Okay, so we have been seeing the type of Grobel weld. It is a square, and the square B type and double B type, and single level, double level, single U level, double U level, single J level, and double J level. So fillet weld we've been seeing the lap plate and streak plate we've been seeing here, and the squatted connection we've been seeing here, and the tree connection is a very common, and the brass it is also very common, and beam bearing plate it is also common. So fillet we've been using the column base plate we've been fillet, and the pipe connection we've been fillet weld, and the beam breaks we have been fillet connection, and build up section we will also use the field weld. Here is the some another welding symbol. This is the important. So we've been seeing that this is the back symbol, this is the fillet symbol, this is the plug or slot symbol, this is another one is the sequence symbol, another one is B symbol, and this is the bubble symbol. This symbol is frequently used, bubble symbol. This is all the global or blood symbol you can see, and U symbol, J symbol, flux symbol, and flexor valve. And another supplementary weld symbol we can see here: blacking, specking, weld all around, and fillet weld, flash, and convex. So in this way we can use the field weld use. This is the we can use frequently, and we can also another use frequently, which is bevel symbol. Here is the bevel symbol, which is the one kind of, we can say, the triangular, and fillet weld. Here is the welding symbol. In our practical field, this symbol we have to understand that this symbol will be designed by the designer or a detailer, and you have to understand that what does mean it. So let's see it, how we'll understand this. So at first we have been try to understand the upper portion, which is the finishing symbol, and this is the contour symbol, and the bottom of the symbol will be the grovel angle of includes angle or crushing for plug welding, and the R, the meaning of R is the rope planing of deplating filling or for the plug and slot welding. Okay, so we have been already seen here the fillet welded symbol, and another one we have been seeing the specification of the process of the other preference, and this is the both and arrows. We have been seeing the welded symbol is the second bracket is given here, and arrow of the connection we have been given the reference line of the member of the arrow side of the member of joint of arrow side of the joint. Okay, so here is the welding symbol we have been used in our practical life. So 3/8 into global 6, and this symbol we have been used the vertical triangle, and we have been seeing the so many symbol are given here, one A, B, C, D in sequentially D, E, F, and G, H, I, J. So these are the different symbol is given here. So if we after the design or detailing, so some welding we have to given in our welding drawing sheet. We have to divide it this type of. So let's see here. Here we can see one half inches gusset plate. So here is the 1/3 in B into E 70, and another one we can see shop welded, and one into 1/2, and one 3/16 and 10. So welder symbol is given here, so you have to put in mind in this symbol. So this is the very most important, I think you have to understand, and you can practice more and more, then you can understand here. If you don't understand, then you can message me or not me. I will try to again deliver clarify this matter. So while welding position, we can see here is the flat position, here is the horizontal position, we can see here horizontal, and this is the flat, and this is the vertical position, and this is the overheaded position. Okay, so let's back to my lecture. Here is an example. I like to the doing to the math rather than the theoretical is so much boring. That's why I'm as engineer you should focus on the math rather than the theory. So let's see. Here is a determine the size and length of the fillet weld for the top for the lap joint in shown figure below. All the plate are 36 steel, Fy is 36 KSI, and F equal to 58 KSI. Use the ASD method. So you can see here the plate is given the thickness 3/8, and the load is given 95 and 95 in the both in axes, and plate is also also given 5/8 into 7. Okay, for we are calculating for a given plate is 5 by 8 into 7, so T thickness we will getting usually 5 by 8, and when we can see the thickness is greater than 1 by 4, which is 5 by 8, then we will use the maximum A, as we seen T equal to 1 minus 16. What is T is given here 5 by 8 and found 9 by 16. So minimum size of A minimum we know the 1 by 4, and the maximum we have been from 9 by 6. So we have been taking the value of A between minimum and maximum A. So we have been already found the A maximum, and we have been already calculating the minimum value. So we have to calculate another A, which is the value is between maximum and minimum value of A. So we have been selected 1 by half, which is the maximum of 9 by 8, and minimum value is 1 by 4. So this is our assumption value. So no one can question you why you will using this. We are using this as our intentionally. We are taking this value between maximum and minimum value. Okay. So effect of the third dimension, we know that TC equal to 0.707 A, as found in previously and found 3.54 inch square, and FEA max is taken 60 KSI. So wild shear flow equal to 0.60 TE and FEX, and found 12.74. And for 7 inch width of the plate shear, we have been using this formula 0.6 into T into FI, and found 13.5. And last one we have been found the plate rupture, which is 0.6 into T into FU, and 21. So on the of the three value, which is the wild shear strength and plate shear and plate rupture, so we are seeing that 12.74 is the minimum value. So we are taking the minimum value. Why we are taking the minimum value? So we are assume that the minimum, after the reaching the minimum value, the section will be collapse or tearing or bearing. That's why we all always consider the minimum value. Okay. So wild strength as per ASD, we have been found 6.37. As per LRFD, have been found 9.55. As in this question, we are not using the LRFD, as question mentioned only use the ASD, but I have been calculating for my self study. Okay, so wide length would be design force. We have been seen in figure, design force is given 95, and divided by minimum wire length, we have been found 3.67 and found 14.95, which is the close to 50 cc. So we must be used in 50 cc weld in our section. So wire length is 15 inches, so we will dividing the 15 inches two portion, is 7.5 is top and 7.5 is bottom. This is the one case. So you can use another case, which is the 4 inches top and 4 inches bottom, which is 8, and another 7 is the right section. This will be totally 15. So this is your assumption where you will be use this wide length. I think the second mode you can use for your assumption. As an engineer, you can judge everything. You can take your own decision, but I will prefer the second one. Okay, so let's see another example. Here is the design of the fillet weld. Develop the full strength of the angle shown in figure given below, and minimizing the effect of eccentricity. Assume the gasket plate does not govern, use the ASCSD method. Okay, so in this picture we have been seeing the lots of information are given here. L6 4 into 3 by 4, F52 on GR 50, it will be 50, and area is given 3.61 and Y is given 1.94. So if we don't give this information, then we can easily take in this information from EIS manual. Okay. So you can see here the 6 inches, and the right section in the bottom horizontal is 4 inches, and thickness is given 3 by 4. Okay. So this what does mean it? This mean this is the length of 6 inches, and 4 means this is the bottom is 4 inches, in x axis, in y axis is y axis 6, and x axis is 4, and 3 by 8 is the thickness, nothing but. Okay, let's see if y bar is not given, then we will calculate in this way, or we'll use the AIS manual. So y bar y1 a2 y2 plus divided by a1 plus a2. So this is the section we know the 4. This is we have been taking the section 1 is here a1, and y2 3 by 8 means 0.707 and divided by 2, and 5.64 because we are deducting some 3 by 8 and found 5.625, and 3.67 is the thickness, and 3.67 plus 5 by 2 625 divided by 2, and found 1.94, which is 1.91 is very close to. So that's why we are avoiding this calculation. In practically you will use the AIS manual for taking the y prime and a value of a. Is nothing but a section 1 and section 2, adding the value of section 1 and section 2, and found 3.61. Material we have been already discussing here, Fy equal to 60, Fu equal to 65, and use E 17 electrode. So when the given Al 60 into 4 into 3 by 4, then we have been taking the only the thickness, which is 3 by 4 inches, which is 0.375 inches square. We have been seeing the 0.375 is greater than 0.25 or 1 by 4, and less than 0.50 or 1 by 2. So minimum fillet size, minimum we are using 3 by 4, and the maximum value we have been max will be T into M by 16, which is 5 by 16. Okay, so this all this we can take in from the also table. So we have to now choose another A, which is the I'm already said that, which will be the between minimum and maximum value. The minimum value have been found 3 by 16 and maximum 5 by 8. So we have been chosen 1 by 4, which is which is our assumption value, which is between minimum and maximum value. So let's add. So effective throat dimension will be T equal to 0.707 into A, and putting all this value and found 0.177 inches square. Okay, let's start. So we know the Fex equal to 60 ksi, and the weld share will be 0.60 T into Fx, and found 7.43. And if we use the ASD method, then it will be valuable 3.72 keep per inch. Now for design for shear force, we have been seeing the yielding strength. We have been using this formula and found 108.1 keep, and for rupture strength we have been found 11 and 1.46. So we have been seeing we are taking the minimum value, as we know that after the minimum value is reaching, the section will be collapsed, section will be failed. That's why you have been taking the 108.8 minimum value. So total length will be key. What will be total length of the weld? The total length will be nothing but total weld will be design force divided by minimum weld strength. So minimum weld strength we have been already found 3.7, and dividing this and found the 29.06 inch. So we are dividing, we are providing 29.06 inch in throughout the channel. So let's see how we'll provide. Okay. So we have been seeing here F1. We have been taking the F1 is in the upper in the top of the section, and the bottom one is F3, and F2 is the middle third. So we know that the total length is 6 as given in question. Here is the 6, so the total is 6. So we are dividing here 3 into 3. And the y bar we are known already, y bar 1.91. We are calculating here y bar 1.94, but it is given 1.91, or we are taking the ASC manual, and that the another portion will be top up for a portion will be 6 minus 1.9, which is 4.09. So we will calculating checking here. So for the force carried by the weld F2, which is angle width, we've been known the 6, and minimum weld strength, which is known the 3.72, and found 22.32 kip. Now we're taking the moment at F1. This is the F1. We're taking the moment in this portion. In this region, we're taking the only F1 in this region. Okay, let's see how we'll calculate. F2 equal to 3. So this is the F2 into 3. So force into perpendicular distance. And F3 equal to 6. Here is the F3 into perpendicular distance is 6. 3 into 3 into 6. And found F3 below 62. In the same way, if we calculate the summation of f of x and summation of f of y, we know the f1, f2, f3 is total Tn. Total Tn, we know the 108.1, and f2 and f3 were already known, and in this way we will calculating the f1, which is 23.8. So all these f1, f2, f3 we are finding in this way. Now we will calculate the weld length is L1. What is the L1? L1 is the where the F1 is. We are taking the F1. This is the L1. So L1 will be force F1 divided by minimum weld strength. We have been taken minimum weld strength 3.72, and F1 we have been taken 23 and divided by 3.25 and found 6.40. And the weld 2, this is the 6.42, and for weld 2, this will be weld 2. Force of F2 divided by minimum weld length, and it will be 6 inches, and this is the 6 inches. Sorry, not bottom. Bottom is this F3, and this way we will calculate the F3, which is force force of F divided by minimum weld length, and found 16.67. Now if we calculate the length, then we will found the 29.06. On the other hand, we have been found 29.06 in previously, which is for design force divided by weld length. So we can see we are dividing 29.06 in F1, F2, F3 region. So this will be our actual weld length. So allowable capacity, minimum weld length minus total weld length. So we can see in here 3.72 into 29.06, which is 108.11, which is greater than the design force is design force 10.11. So this is okay. So there is no question at all. So let's see another example for eccentric welding. So this is the dangerous for all the designer. So compute the maximum load or stress kip per inch on load and weld configuration shown the bracket in figure given below. Figure assume the plate thickness and thickness does not affect the result, and use the elastic vector method. So elastic vector, we have to use the elastic vector method by using the this. We can see the picture 1, picture 2 and picture 3. All this we are taking divided the CG. X bar we are taking 6 into 1 into 6 by 6 divided by 2. This is the 6, and thickness is 1, and divided by 2, and 6 divided by 2, and 8 into 1 into divided by here is a 8 into thickness is 1, and there is no when you use the X bar, and there in the X bar there is no Y distance. In the same way we are using this one, 6 into 1 into 6 divided by 2, and found 1.01. okay, we are taking from x-axis is here. So Y bar we can use 6 into 1, so we've been seeing 6 into 1 into x into 0, and 8 into 1, 1 is the thickness, and 8 divided by 2. For y-axis we have been taking 4 inches square. So AM will be force into perpendicular distance. Distance in force we have been known the 15 as given in question 15, and 12. How will get the 12? 12 is 12.5 is 16, minus x bar, which is 1 minus 4 plus 8, and found in this way we have been found 12.2. RB force into weld length, so we have been found 0.75, and moment of inertia we have been found 235.65 m. In y direction we have been found 75.55 inches square. The polar moment of, if you calculate the polar moment of inertia, that will be summation of f of ix into y, so which is 311.25. Stress due to movement, if we calculate here my by I and found 2.35 cube feet. In this way, if we calculate the y bar, then we will take the mx instead of y and found 2.47. If we calculate the resultant force, summation of f of x plus summation of y, so y is taken the 2y y plus rb. Here is the rb, and found 3.9 cube inch square. This is our result. So the lecture is ended, but I want to share some which is taken for Hibbeler books or semester 2. There is the two type of welding we know here: fillet welding and bolt butt welding. So calculate the length of 3 divided by 4 weld joint. What will be length? So given thickness we have been seen here 0.50 and thickness 0.60 in plate and 0.50 is channel, and axial 4 is 50 and allowable bearing stress is 60, and figure is given here. All the figure is on, all the dimension is given here. The for weld AB, so this is the AB portion. The axial force in resistance by force, axial force minus length into total length. So axial force we know the 50 is given here in question, and 1.75 is the bottom portion, and divided by total length 1.5 plus 3.25 and found 17.5. And CD will be same way, but the thickness that length will be changed, which is 3.25, and total length will be remain same. And the weld length of R L, which is F divided by 0.707 allowable into channel thickness. F is taken the 17.5 as we found here AB. For CD the F equal to 32.5 and found the length 4.25 and 7.75 respectively. And then we can see the for weld AB and CD, the weld length of AB and CB can be reduced if the connection is double on AB also. For the resultant of weld force to pass through the centroid, the weld length of AB can be D equal to 1.5 into 2. So we are multiplying the double of 1.5 into 2, which is 3 inches. These levels are weld of length 4.13 inches square. We have been found 4.13 into 7. This is the 4.13 and 7.77 minus 3, which are 7.7 inches to be divided on the AB and CD. Okay, so now we'll divide it here. 1.75 is the load we are knowing. We have been found 1.7 is the length for AB, and CD equal to 3.25, and divided all things and found 3.08, which is taken the 3.25, and for CD 5.75, and AD we have been taking double 1.25 into 2, which is 3 inches. So all 3 inches, all this diameter we are using, all this length we have been using here. So that's all. If you have any question, then let me know. This is taken for SM2 or pop-up books, and this if you have any question, let me know. I will try to convince your answer and giving some answer. Thank you everyone. Thank you your patience.